Hello, I'm Andrew Smith, Chair of TM257 at the Open University, where we are going to be exploring Module 9 Address Resolution as part of the Cisco Introduction to Networks course. I think, yeah, we've covered ARP already a couple of times in a couple of different webinars, but it's great because it's good to recap and it's good to go into a little bit of depth and explore how MAC Media Access Control and ARP Address Resolution Protocol makes a difference to the behavior of a network. The reality is, on a network, a computer will know its own IP address and its own MAC address. It might know a remote IP address. Well, you're going to ping it or send traffic to it, or it might be a DNS server, anything like that. But it doesn't know from a data link layer perspective the MAC address, the hardware address, which it needs to put in its local routing or host table. So to do that, when you send a message to another device, the first thing it will do is send an ARP, an Address Resolution Protocol, message to discover what the MAC address, to put it in its local table so that it knows then who it's talking to, how to talk to it on a layer 2, on a data link frame basis. So yeah, we've been using this technology for very long time, probably 30 plus years, and it's happening all the time. Your computers are doing ARPs all the time for local devices or for the default gateway or even for the local network wireless printer if it works. So we can do that local network. Obviously, if you do an ARP and it ends up being a device that is across the system on another device, then what will come back is the MAC address of the default gateway. So I'm going to build a very simple example shortly where I'm going to use this network and I'm just going to eventually do a ping across, and we'll see the ARP between routers, or between routed domains, should I say. And then I'm going to add another PC and we'll actually see the ARP locally as well. This is all sort of very straightforward networking fun. Ping on IP version 6 does this slightly differently, so it's used to actually associate the layer 6 128-bit address, and we can do that. And I'm going to do this using this practical lab. You could actually do this using packet tracing. It's a worthwhile packet tracer activity. ARP, as I've already said, goes out, it finds the address, and we're just trying to build up a MAC address table. I'm not going to read from the slides because I think you're quite capable of reading for your own good selves. But the important thing is, and if you don't understand how networking works, the ARP cache is purged, and it's purged probably every 3 minutes. So it's a long time to live on a network, and if you're not talking to a device for 3 minutes, well, that's a long time, so you won't be talking to it again. So it's cleared, and then if you send another message to it 3.5 minutes later, it will do another ARP and send that traffic out. And what I'm going to do is actually going to show you the show IP ARP, and I'm going to show you the ARP minus A's shortly on my practical network. But it can be spoofed, and it can be spoofed for a threat actor. Legacy, it used to be called man in the middle. Now we often call it person in the middle, or ARP poisoning, and that is where you can actually change your MAC address. And basically, by having a shorter time to live and having a shorter MAC address, we can actually spoof the device that you're actually talking to. Can do that, and I'm just going to mess with a MAC address to show that these things can be easily done. And we will actually, you can do the online curriculum exploring the ARP table, but I'm going to do this using my practical lab. IP version 6, where it uses neighbor discovery, neighbor solicitation, neighbor advertisements. So it's always going out and saying, hello, who's out there, and what is on my network, to build up a table of devices, which is similar to the way that ARP works. So it's going around saying, yeah, who's on my network, who am I going to talk to, and who's going to be connected as part of my community. I'm not going to do IPv6 just because of time, but you can actually go and do this excellent packet tracer lab that is available on the Cisco Academy curriculum. So let's go and look at this network here. And what I'm going to do is enlarge this screen a little bit more and move this slightly into the middle so we can all see what's going on here. So we've got a simple network set up here. If I actually look at the IP configuration, we've got a 10 dot network over here talking to a local default gateway, and over here we've got a 192 network talking to the local default gateway. Nothing clever. And this router is quite basic in its configuration as well. If I enable do show run, you can see that I've just got these two interfaces set up as the default gateways. Nothing clever. No routing protocols, because if you're unaware, Cisco routers will route directly connected without a routing protocol. They won't route any further, but they will route directly connected. So if I now do, and I will do this for so I have tested this earlier, I am now going to ping 192.168.0.1. So I'm going to ping through the router to the opposite. And hopefully we should see that a couple of packets are dropped, because IP doesn't worry about things like that, as you probably heard in the previous lecture. And there you go, packets dropped because ARP is taking place. And we can now actually see that the message has actually travelled across the network. And if I do ARP-A, you can see that it's actually got the address of the default gateway and the physical MAC address of the default gateway as well. It hasn't got the address of the fire point because it's not on the local network. If I go to this device here, which I've done nothing with, and just do ARP-A, you can see it's also got now in its host table the MAC address and the IP address of the default gateway, because I sent a message through and as I had to reply back, it was going to talk to the local router. It doesn't have the FAR address. It wouldn't. It's not on the local network. And if I actually go and hit enter and do show IP ARP, we can see the whole host table for all of the devices that it's seen. The local router interface address for the default gateway, and the PC addresses, their MAC addresses as well. So this is all working quite well. This is normal. Okay, ARP has taken place. The router's built up a host table. Each local device has built up a host table as well. Now, to sort of prove the point effectively, I'm actually going to now go into this network here, and I'm just going to add another device, and I'm going to put this on as 10.0.0.10, and I'm going to make sure it's got the right default gateway. Remember, we're doing really basic networking here. We're not doing anything clever. I'm going to throw a switch in. I don't need anything clever here, but I am going to move that cable. Oh, I didn't want to do that, sorry. When I deleted the wrong thing unintentionally. I'm now going to throw in some proper cables. It's going to connect to the switch. We're going to treat this as a dumb switch. We're not going to worry about configuring a switch at all. I've got everything connected back. It's going to take a moment. I'm just going to fast forward time for speed. Now again, I ping, so I should be able to ping 192.168.0.1, and there you go, because obviously the router now knows where it's going, so it's a lot quicker. So it's talked to the router knows where it is, it's passing it through, it's passing it back. But now, if I do ARP minus A, of course it can only see the default gateway. But if I ping 10.0.0.1, which is on the local network segment, it's done an ARP within the local network segment, and it's now got the local MAC address because it's not passed through the router to actually do that. So it needs to know it locally. The router knows where it is. It also knows where it is, and it's not afar. It's not outside the network segment. But this is where we could have some fun. So I am going to go into this device, into the config, into fast info, and I'm just going to change that to C001, okay, or cool, okay, just change that. So, and I'm going to change that to DAD, dead, so whoops, learn to type Andrew, dead cool, okay, because you can do this in hexadecimal. And now I am going to start pinging across the network. And I am going to ping my buddy 10.0.0.10, which is that device that I created. Okay, I've just sent this new traffic out. I've pretending I'm a person in the middle. I'm doing some ARP poisoning. It's very crude. But now if I look at my ARP table locally, can you see it has changed? It is dead cool. And what often happens in ARP poisoning is this is changed faster than the actual device's MAC address. It's not actually done on the MAC address. You can configure them. It's actually done on another device pretending to be my device, and it's doing the updates quicker than the actual device itself. And of course it's then intercepting the traffic and pretending that it's the default gateway. So now if I go into here and just do mark, you can see that it's now got this address. Also the new devices on the system as well. Now there are ways of spotting ARP changes or MAC changes. There are ways of spotting more than one MAC for the same IP, and yeah, there are techniques available to actually prevent this. So it's important to be aware. It's important to be aware it can be changed. It's important to be aware we can change MAC, but it's important to be aware, very aware, that we actually have to map IP addresses to MAC addresses. We have to get our layer 3 connected to our layer 2 so that we know what we're talking to. Yeah, we can actually have multiple IP addresses running off of the same MAC address, and we know which device is offering what service in some cases. So obviously you found this useful. It's not difficult to configure. As I said, all I've done was just create a router with two adjacent devices that are up. And then obviously I've router connected. I eventually threw switch in just so we could actually see the local network segment. So thank you very much. I'm Andrew Smith from the Open University, and hopefully you found this quite useful.